In this educational video, we will learn the following items. 1. What is asbestos? 2. How is asbestos used? 3. Health effects of asbestos exposure. 4. Regulations and laws related to asbestos. 5. How to safely handle asbestos. 6. Asbestos removal procedures. 7. Asbestos testing and inspection. Asbestos is a naturally occurring mineral that has been used in a wide variety of products due to its unique properties, such as its heat resistance and durability. Asbestos fibers are strong, flexible, and resistant to fire, heat, and chemicals, which made them ideal for use in construction materials such as insulation, roofing, flooring, and cement. Asbestos is a collective term for several types of fibrous minerals that can be separated into thin, durable threads. The most commonly used types of asbestos are chrysotile, amosite, crocidolite, anthophyllite, tremolite, and actinolite. However, chrysotile asbestos is the most common type and accounts for over 90% of the asbestos used worldwide. Although asbestos was once considered a miracle mineral due to its numerous practical uses, it is now recognized as a serious health hazard. When asbestos fibers are inhaled, they can become trapped in the lungs and cause various health problems, including lung cancer, mesothelioma, and asbestosis. For this reason, asbestos is now heavily regulated and banned in many countries.
Asbestos types by AHERA classification. Technically speaking, asbestos is a commercial and legal term encompassing multiple types of minerals. The Asbestos Hazard Emergency Response Act, AHERA, classifies the asbestiform varieties of the following minerals as asbestos.
Chrysotile, white asbestos, is the most commonly used form of asbestos. It can be found today in the roofs, ceilings, walls, and floors of homes and businesses. Manufacturers also used chrysotile asbestos in automobile brake linings, gaskets and boiler seals, and insulation for pipes, ducts, and appliances. Amosite, brown asbestos, was used most frequently in cement sheets and pipe insulation. It can also be found in insulating boards, ceiling tiles, and thermal insulation products.
Crocidolite, blue asbestos, was commonly used to insulate steam engines. It was also used in some spray-on coatings, pipe insulation, plastics, and cement products. Anthophyllite was used in limited quantities for insulation products and construction materials. It also occurs as a contaminant in chrysotile asbestos, vermiculite, and talc. It may have a gray, dull green, or white color.
Tremolite and actinolite are not used commercially, but they can be found as contaminants in chrysotile asbestos, vermiculite, and talc. These two chemically similar minerals can be brown, white, green, gray, or transparent. It's worth noting that asbestos minerals are made up of long, thin fibers that can easily become airborne when disturbed, such as during demolition or renovation work. Therefore, it's important to handle asbestos-containing materials with caution and follow proper safety protocols to minimize the risk of exposure. Asbestos has been used for thousands of years, but its use became more widespread in the industrial era. It was used in a wide range of products, including insulation, roofing, flooring, textiles, and auto parts. However, the health risks associated with asbestos exposure were not fully understood. These are the few names where asbestos may be found. They are roofing and gutters, gables and eaves, downpipes, walls and ceilings, vinyl, carpet, and tile underlay, lining behind wall tiles, imitation brick cladding, fencing, splashbacks in wet areas, electrical meter backing boards, telecommunications pits, window putty, expansion joints, packing under beams, concrete formwork, outbuildings.
Next, we will learn the health effects of asbestos exposure. Asbestos exposure can lead to several health problems, including asbestosis, lung cancer, mesothelioma, and other respiratory diseases. The risk of developing these diseases increases with the level and duration of exposure to asbestos fibers. Asbestos fibers can become lodged in the lungs and other tissues, causing inflammation and scarring over time.
Asbestosis is scarring in the lungs caused by breathing asbestos fibers. Oxygen and carbon dioxide do not pass in and out of scarred lungs easily, so breathing becomes harder. Asbestosis usually occurs in people who have had very high exposures over a long time, but years may pass before any symptoms appear. Pleural disease is a non-cancerous lung condition that causes changes in the membrane surrounding the lungs and chest cavity, pleura. The membrane may become thicker throughout, diffuse pleural thickening, or in isolated areas, pleural plaques, or fluid may build up around the lungs, known as a pleural effusion. Not everyone with pleural changes will have problems breathing, but some may have less efficient lung function.
Lung cancer is a malignant tumor that invades and blocks the lungs' air passages. Smoking tobacco, combined with asbestos exposure, greatly increases the chance of developing lung cancer. Mesothelioma is a rare cancer of the membrane that covers the lungs and chest cavity, pleura, the membrane lining the abdominal cavity, peritoneum, or membranes surrounding other internal organs. Signs of mesothelioma may not appear until 30 to 40 years after exposure to asbestos.
Many countries have implemented regulations and bans on the use, handling, and disposal of asbestos to protect public health. These regulations vary by country and may include requirements for workplace safety, asbestos testing and removal, and proper disposal of asbestos-containing waste. Some countries have banned the use of asbestos entirely, while others still allow certain types of asbestos to be used under strict conditions. For reference, please visit the EPA website. Handling asbestos safely is crucial to minimize the risk of exposure to harmful asbestos fibers. Here are some guidelines for safely handling asbestos. 1. Educate yourself properly. 2. Use personal protective equipment, PPE. 3. Learn the work area preparation. 4. Use the wetting down process. 5. Carry out the controlled removal step. 6. Use the sealed containers. 7. Follow the rules of cleanup and decontamination. 8. Use the proper disposal method. 9. Get professional assistance. 10. Do regular monitoring. Remember, the safe handling of asbestos is essential to protect yourself, others, and the environment. Always follow local regulations, guidelines, and best practices to ensure the proper management of asbestos-containing materials. Asbestos testing is the process of analyzing samples of material to determine whether they contain asbestos fibers. This can be done through visual inspection, laboratory analysis, or a combination of both. Testing is typically performed by trained professionals using specialized equipment and should be conducted whenever there is a risk of asbestos exposure.
There are several methods for testing materials for asbestos content, including visual inspection, polarized light microscopy, PLM, transmission electron microscopy, TEM, and scanning electron microscopy, SEM.
Visual inspection is the simplest and least accurate method for determining asbestos content and involves visually inspecting materials for signs of asbestos fibers. This method is not always reliable, as some asbestos fibers may be too small to be seen with the naked eye.
PLM is the most commonly used method for asbestos testing and involves analyzing a sample of material under a microscope. The sample is first treated with a solution that dissolves non-asbestos materials, leaving only the asbestos fibers. The fibers are then analyzed under a polarized light microscope, which allows analysts to identify and quantify the asbestos content.
TEM is a more advanced and accurate method for asbestos testing and involves analyzing a sample of material using an electron microscope. This method is typically used for analyzing very small or low-level samples and can detect asbestos fibers that are too small to be seen with PLM. Here, we can see photos of the TEM instrument, TEM images of chrysotile asbestos, and the TEM spectrum of chrysotile asbestos.
SEM is similar to TEM, but provides a more detailed view of the sample by scanning it with a beam of electrons. This method is often used in conjunction with TEM to provide a more comprehensive analysis of asbestos-containing materials. SEM instrument, SEM image, and SEM-EDS spectra of asbestos fibers are shown in these photos.
X-ray diffraction, XRD, is another method that can be used for asbestos testing. XRD works by shining an X-ray beam onto a sample of material, causing the atoms in the material to diffract the X-rays in different directions. By analyzing the diffraction pattern of the X-rays, scientists can identify the mineral composition of the material, including whether or not it contains asbestos. XRD is often used as a complementary method to PLM, as it can help confirm the presence of asbestos fibers in a sample that has already been analyzed with PLM. However, XRD is not always reliable for detecting low levels of asbestos, and may not be able to detect all types of asbestos fibers.
For further reading, some reference papers are also shown here.